All right, I told you that I would explain and go through breakpoints with you in this as part of this debugging class. I talked at the last portion of the lecture, talked about how important this was in terms of once you know you have a problem, hunting down where it is. And so I just want to go over very quickly how to set breakpoints, how to run with breakpoints, and some of the information you're going to get here in what we call debug mode when you're running in debug mode, which allows you to stop at these breakpoints, pause, take a look at the environment and what things look like before you move on. First of all, you'll notice that I have a couple of different breakpoints set. You're only going to be able to set a breakpoint on a line that does something. So you can't set a breakpoint, say, here at line 17 where it says Boolean more. I can't set a breakpoint here. It won't let me. The reason it won't let me is because there's nothing going on. I can only set a breakpoint where a value is assigned to a variable or some action is taking place. To set a breakpoint, I'm just going to click on the line number, and what we will do is we will see a red dot appear. That means that's going to be a place where we're going to stop. The code isn't going to be executed until after we move through the breakpoint. To run this and make sure that we stop at the breakpoints, instead of using the plus sign, or if we go up here to run, I'm going to either go to debug and debug project, or I'm going to click on this little icon here where you see the little breakpoint, the line numbers, and the plus sign. Either of these will work. This is going to run it in debug mode. That means that the program is going to compile, it's going to run, and it's going to stop at the first breakpoint. When we've stopped at a breakpoint, we're going to see a green arrow over by the line number, and the entire line is going to light up in green. This lets us know that this is where we are right now. When we are working with breakpoints, one of the things that we can do is we can find out what the value of all of the current variables are that are in scope. Now remember, a variable scope is defined as the moment that we run across the code until the end of the block in which it was defined. So that means that I can see everything that has been created so far that is inside the main method. So as you can see, nothing's been created yet. We stopped here at line 16, which is the first thing that our main method does. We do have some static variables up at the top for the print writer, standard out and standard in. And if we click on the static button here, you will see that we've got a print writer class, standard out, and we got a print writer class, standard error. The first thing you'll see is the name of the variable, and then the type, and then the current value. If it is a complex type, like a class type or an object, you're going to see a number here. That number is representative of an area of memory. Rather than providing you a hexadecimal address, it provides a numeric address. You see these args here. That's a string array, and that's going to be whatever's passed into the main method's string arguments. Again, I realize we haven't talked about arrays yet. We'll do that a little later in the semester. When we want to move on to the next breakpoint, we don't hit this play button over here. Instead, over on this side, we have some controls. We have a stop or a finish debugging, a pause, a continue that lets us move on to the next item, step over, which prevents the code from running and lets us move on, step over expression, step into, and step out of. Additionally, we can also see the amount of memory that our program is taking. So I'm going to go ahead and click the continue button to move on to our next breakpoint. Now you can see that we've got some other stuff going on here. We've got a variable called score that's been created and assigned the value 0. If we move to the next line, we'll see that we've now created a scanner object called input. We've printed out something. To see the printout, we'll click over to the Output tab. And after we flush the line, we'll see a request to enter a score. At this line, we're going to ask for the score. And I'll just go ahead and enter 65. and hit return. And if we go back to our variables tab, we'll see that our score variable now contains the value 65. Now we're starting to run through our loop. If we want to see what breakpoints we have, we can look at all the breakpoints that are set by clicking on the breakpoint tab. We can deactivate a breakpoint, we can select a group of breakpoints, or we can create a new one, all right from this panel. The big thing here is being able to stop the code and sort of see the landscape. What are the variables? What are their values? What objects exist? What objects don't exist? We can see that all from right here. This is extraordinarily useful when things just don't look right and you can't figure out why. And I use this very often, not only to slow the program down, to show you how things run and to show you how control structures work, but also when I'm looking at a program and something's not working right and I just can't figure out why it's not running the way I want. This isn't going to help you find compiler errors. The compiler will let you know where the problem is. This is a tool that's going to help you at runtime. When things aren't looking right at runtime, why aren't they looking right? What is going on? You can use this in conjunction with your unit tests if you're writing a class library. If you're writing an application, then your best bet is to just use these to help figure out where your problems are by repeating the behavior. This is going to be the last demonstration in our testing and debugging lecture. I realize there's not a whole lot of information here. I realize not a lot of this is immediately applicable to what you're doing, but I think it's very important that you understand how to find out where there are problems in your code. As you start building more and more complex applications, as you start being asked to just write class libraries, sometimes you want a way to test these things, and you want a way to test the stuff that you've written outside of the application. This is a really good way to do that, especially when you're just building an application, just building a class library as opposed to an application. The application you can interact with, so you really can test it a little more easily than if you were if you're writing a class library and you've got no driver program to run it. Again, if you have any questions about anything we've covered, please feel free to ask me. There's going to be a short 5-question quiz on the materials that we've talked about today, on some of the information that we've talked about today, and how these things can help you. There are also going to be additional PDFs that I use to put this lecture together, including a quick outline, as well as some additional information on JUnit testing and static code analysis. Thank you very much.